All right, welcome to our final unit when we are going to talk about space. So here's the really nice thing about space. It's super interesting. Most of you have really excellent questions about it. Here's the downside for space and why we don't spend as much time in it. There is very few of you that unfortunately will go on to study space. Some of you might take it in university, but space is actually not a unit in grade 10 science, and it's actually not offered in grade 11 or 12 either. So this is actually going to be the last time you see space unless you choose to study it in university. So we try to do more of a chemistry, physics, biology background in grade 9 because that's what you are going to see again in high school. So let's start by talking a little bit about what the universe and what's out there. This is just a really base knowledge. You probably have a lot of this knowledge already, but it talks a little bit about the different things that you can see in the night sky. First of all, let's go ahead and let's define what astronomy is. Astronomy is said to be the study of the universe and objects in it. Do not confuse this with astrology, which is like horoscopes. So astronomy is a study of things actually in space. Astrology is if you're a Taurus or not. Astronomy helps to study celestial objects. What a celestial object is, it's an object that you can see in the sky. There's actually lots of different categories of celestial objects. So that's one of the first things we're going to do is categorize celestial objects. The biggest way that we can categorize them is by using the word luminous or non-luminous. So these are two words that you're actually going to see in grade 10 physics again. Luminous means gives off light themselves. Non-luminous reflect light. So you actually might be looking up at the night sky and thinking, hey, everything up here looks pretty bright. Well, some of those objects are creating their own light and some are just reflecting the light of others. They're still going to appear bright, but they're not actually giving off their own light. Examples of luminous objects are stars. A great example of stars is our sun. Non-luminous objects, the moon. So the moon actually doesn't have any of its own light. It's actually just reflecting the light from the sun. Planets are also non-luminous objects, as are comets. So a little bit about what's in our universe. So we have, we have our sun. You can see it's fairly massive. And then we've actually got our solar system here. So we can actually see all these planets in order. So we're going to take a little bit of an overview of each of these planets. Now that's not obviously the entire universe. This is really just the most studied part of the universe, our solar system. There's lots of things outside of our solar system. And as technology develops, we're able to see further and further into the universe itself. So one thing that's in I'm going to shrink this down a little bit just so you guys can see. Can I zoom out? There we go. That way you can kind of see this on one slide. So one thing that makes up the universe is the planets. So I've got a list of all the planets here. Again, we're going to go in them in greater detail. And our planets are, of course, in order. And all of these planets do have orbits. So you can see each of the orbits here, and each of these planets follow an orbit. Another example of, no, sorry, I lied. We have to talk first about what it means to be a planet. So there's actually rules around being classified as a planet. There's other things in the universe that are not planets because they don't follow these three rules. So the first rule is that a planet must be in orbit around a star. So on that last picture, you can see all of the planets were orbiting around a star. Our star in our solar system is the sun. A planet must have enough mass to be pulled into a stable sphere by gravity. So a planet has to be big enough that all of its gases and all of its atmosphere gets pulled into a sphere because they've got enough gravity. So if you look at that picture I just showed you, all of them had a circular shape. All planets are sphere shaped. And lastly, a planet has to dominate its orbit. So I did mention that planets orbit around the sun. A planet has to dominate its orbit, has to be the most important thing in its orbit. If there's anything else that it orbits other than the sun, it's not dominating its orbit. It's not considered to be a planet. So its mass must be greater than anything else that crosses its orbit. Interesting fact, when I first learned planets, Pluto was a planet. Now Pluto is not a planet. The reason Pluto is not a planet is because it doesn't dominate its orbit. It actually gets crossed off by something else. So Pluto satisfies rule 1, satisfies rule 2, but it doesn't satisfy rule 3. So they took away its planet status. Let's talk a little bit about the planets. Now, you actually don't have to know details about the planets, but they're just so cool. So I do have a pretty neat documentary that I linked at the bottom as well too. It's pretty long. It's just more for like rainy day watching. Don't watch it if you don't have time. You're not going to be tested on it. But learning about the planets is just so neat, and we really just don't have a lot of time to do it. So, a little bit about Mercury. Mercury is the closest planet to the sun. Mercury is small, hot, and the reason it's so hot is because of how close it is to the sun. The next planet in order is Venus. Venus is sister to the Earth. So, what we mean by sister is in terms of properties, they're actually really not very similar, but they're very similar in size. So, the Earth and Venus are very similar in size. They're the same density, they're similar chemical makeups, but in terms of the atmosphere on Venus is very inhospitable compared to the beautiful, friendly atmosphere that supports life on Earth. Then we have the Earth. I don't have any points about this because we've been studying this Earth for so long, right? Just think of the ecology unit. So the Earth is the third planet from the sun. After the Earth, you have Mars. So this is a nice picture of Mars. Mars is considered to be the red planet. The reason it's red is because there is so much iron. Iron, when exposed to certain gases, will rust. So the fact that Mars has a lot of iron, it means that it's got a really, really, really rusty exterior. And that rusty exterior is what's giving it that red color. Next planet is considered to be Jupiter. Jupiter has been nicknamed the failed star, and this is just based off of its size. So Jupiter is by far the biggest planet in our solar system. It's very large, and it's also got something called the Great Red Spot. You can see it right there, and that's actually just a storm of swirling gases. Saturn is the next planet. It's called the ring planet. It's actually not the only planet with rings, but its rings are really nice and really visible. So it leads to the misconception that it's the only planet with rings. Uranus, as you can see, or Uranus, as you can see, also does have rings as well too. The reason that we actually have the rings here is that this shows that Uranus actually flies along on its side. So you can actually see that Uranus is actually going through on its side, on its tilts, compared to the other planets. So it's kind of like flying through space on its side. It's pretty cool. After Uranus comes Neptune. Neptune is far from the sun. It's the farthest planet from the sun, so it is considered to be very cold, and it actually has something called the Great Dark Spot, in contrast to Jupiter's Great Red Spot, which is right here. There's also these things called the dwarf planets. So these dwarf planets are spherical. They do have an orbit. They don't dominate their orbit, so they can't be classified as planets. Instead, they're classified as dwarf planets. So we have Pluto, we have Aries, and we have Ceres over here. They're all considered to be dwarf planets. A little bit more about dwarf planets. Dwarf planets orbit around the star. They have enough mass, but they do not dominate their orbit. So this actually just shows Pluto's orbit and the fact that Pluto doesn't dominate its orbit. You can see here the orbit of Neptune, and you can see that the orbit of Pluto isn't totally centered, and the orbit of Pluto, it actually comes in path with Neptune here. That means it doesn't dominate its orbit, so it lost its planet status. All right, let's talk about some more celestial bodies or some more celestial objects. So these are things that are not planets, that are not dwarf planets, that you might still see in our solar system. So moons are example of celestial objects. We're not going to list all the moons. We're actually very self-centered here on Earth because we named our moon, but there's actually lots of other moons on other planets. There's lots of planets that have more than one moon. Moons are, we also call them satellites as well too. We're going to talk about them in more detail later. Moons are satellites. They're natural satellites that are orbiting around a planet. Asteroids. Asteroids are big, massive things in space. Asteroids are composed of rock and they're also composed of metal. They're found in the asteroid belt, and that asteroid belt is between Mars and Jupiter. So I'm going to go back up here just for a second, and I want to show you this asteroid belt because it's going to help you make a distinction between the planets. So we're going to take another quick look at the planets. So much scrolling. Almost there. Here we go. So we're going to take another look at the planets, and the planets actually have an asteroid belt right between Mars and Jupiter here. What that does is it helps to separate out. We call these the gas giants, and we call these the rocky planets. So Mercury, Venus, Earth, and Mars are considered to be the rocky planets. And then we've got this asteroid belt, and then we've got these things that are called the gas giants over here. You can see how much larger these planets are to these planets over here. So that asteroid belt helps to tell the difference between the gas giants and the rocky planets, or the inner planets and the outer planets. All right, let's go back to asteroids and let's talk a little bit about them and how they're different than comets. So again, asteroids are composed of rock and metal. They can be incredibly large, as in 1,000 kilometers across, or they can be as small as a pebble. So any sort of flying rock or metal through the universe is considered to be an asteroid. Some are much larger than others. We also have something called a meteor. You might have seen a meteor go across the sky before. It looks like a nice streak. Each streak is a piece of rock or dust as it burns up as it enters our atmosphere. So as a piece of rock or dust enters our atmosphere, it burns up. It causes this nice little streak here. The rock itself is called a meteoroid. And if the rock hits Earth, it's called a meteorite. So while the meteor is still in the sky, the rock part here, not the tail, but the rock, is considered to be a meteoroid. And the actual rock, if it hits the Earth, is called a meteorite. Now let's talk about comets. So comets are different than asteroids. A lot of people do mix them up. Comets are considered to be great dirty snowballs. So what that means is comets are made up of dust and ice. That's different from asteroids, which are made up of rock and minerals. So comets have two tails. You can actually see them in this picture here. So they have something that's called the dust tail. That's the yellow up here. And then they also have something that's called the ion tail. That's the blue that's down here. Something else that is in our universe, considered to be a celestial body, is stars. We're going to have a whole separate lesson on stars. We're going to learn about them in a little bit more detail. Stars are actually just massive collections of gas, and stars actually emit large amounts of energy. So we did mention before that stars are considered to be luminous objects. They do have their own energy, and they give that energy off in the form of light. We mentioned this before, but I want to mention it again. I want to make the distinction between the rocky planets and the gas giants. So the rocky planets are considered to be the inner planets. So you have Mars, Mercury, Earth, and Venus. When Pluto was considered to be a planet, it was categorized as a rocky planet. Notice that they're much smaller. We're going to compare them to our gas giants. So we have our gas giants here. This is proportional to size. So you can see our gas giants are quite a bit larger. Look at how much larger Jupiter, look at how much larger Saturn, look at how much larger Uranus and Neptune are compared to Earth, or compared to Venus, or compared to Mars, or Mercury, or this little speck is Pluto. So we have our gas giants much larger than our rocky planets. These are considered to be the outer planets. These are considered to be the inner planets. So that was a really great overview of just what's in the universe. Now we're going to have some separate lessons about maybe how the universe came to be. Pretty interesting. Big Bang Theory. We're going to cover that next, as well as take a closer look at some of those celestial objects. I did post a video below that I strongly recommend watching. It's featuring Suni Williams. She's a female astronaut, and she actually takes you on a tour of the International Space Station. It's really cool. It's like 20 minutes. Best 20 minutes you're going to invest today. So she actually brings you up into space, and not only does she take you on a tour of the International Space Station, but she also talks about some of the challenges while living in space. How do astronauts work out? How do they eat? How do astronauts go to the bathroom? I'm sure you've always wondered that. So if you have 20 minutes right now, I would strongly recommend watching that video, and we'll see you in the next lesson when we talk about the Big Bang Theory. Have a great day, and we'll see you later. Bye.